Good day, everyone. My name is Abimbola Folakemi, a student of Oxford Brookes University. I am here to introduce you to my simulation, which is an integration of BIM and Power BI for on-site health and safety management. This simulation was prepared for the purpose of my dissertation towards earning a master's degree in construction project management in the School of Built Environment from Oxford Brookes University. I am being supervised by Professor F. Henry Abanda. This simulation is to improve health and safety in the construction industry. Globally, the construction industry plays a significant role by creating jobs and improving a country's physical infrastructure. However, numerous studies also shows that the construction industry have the highest accident rates, ranging from incidents, accidents, near misses, and even deaths. Therefore, to efficiently deal with these wide varieties of catastrophe, the construction sector or industry must adapt new technology. BIM, which is Building Information Model, and Power BI are two examples of technology-driven solutions that may be used to address this situation. BIM improves health and safety management on building projects by offering data-rich 3D models that boost communication and collaboration among all parties involved. Both hazard detection and risk evaluation are essential parts of health and safety management, and both may be accomplished using building information model, which is BIM. Health and safety management might also benefit or will surely benefit from the combination of BIM with Power BI, allowing for a real-time data analysis and insight. This goal will be accomplished using BIM and Power BI by integrating them together for on-site health and safety management, which will minimize accidents, incidents, near misses, or even deaths, and improve the industry image and reputation. Therefore, I would like to take you through my simulation process, which is taking you through my simulation flowchart. From my flowchart, we would identify the project. The project for the simulation, for the purpose of the simulation, is a 4-bedroom duplex, which is developed in Revit, and the 3D is being developed in Revit. From the Revit 3D model, we're able to integrate the 3D into Naviswork, where the program of work will be developed. From Naviswork, we're able to integrate our risk data. After integrating our risk data, we're able to export our data via CSV files to Excel. From Excel, we're able to readjust our data in Excel before or after exporting it to Power BI. After exporting our data to Power BI, we're able to develop our visuals in Power BI. Taking our model, which is developed in Revit, which is this. Developing our 3D model in Revit and our design in Revit. After designing, we're able to export our design from Revit to Naviswork. Here in Nevis work, we were able to develop our program of work, which is more of a schedule of accommodation, showing the start date and the finish date of each of our construction activities and even the end of the project. Through the use of custom tools here in Nevis work, we were able to integrate our health and safety elements, which is hazard types, severity of hazard, likelihood of hazard, effective personnel and mitigation. However, on Nevis work, we were not able to fully integrate our health and safety elements or data because Nevis work do not give permission to fully insert our health and safety data. Therefore, we'll be doing our health and safety data or creating our health and safety data manually by exporting our data sheet here via CSV files to Excel. After exporting our CSV files, after exporting our data via CSV files to Excel, we're able to manually generate our Excel data spreadsheets. So here on Excel, we're able to develop our data values here. So we're able to integrate our health and safety elements, which is hazard categories, types of hazards, likelihood of hazard, severity of hazard, and the mitigation, and even the effect of hazard. After we're able to manually create our Excel spreadsheets, our health and safety spreadsheet, then we're able to go to our Power BI, where we'll be creating our visuals or our dashboards. When we open the Power BI desktop, this is what we'll find. This is how the face looks like. And then we'll go to the import data from Excel bar. Then we're able to import our data sheet from Excel. After importing our data sheet from Excel, it takes us directly to the board. From here, we're able to click on our spreadsheet. There we have our spreadsheet. If we are okay with the spreadsheets and our data formulation, we'll load it. However, for the purpose of this, we're able to notice that Power BI do not obey complicated data values. Therefore, we will be transforming or readjusting our data values to the one that Power BI could easily understand. So here, we're able to delete columns that are not health and safety related. Then we're able to transform our data from this complicated data values into a simple data values that Power BI would obey easily. After readjusting our data spreadsheet, we're able to have our data values has simple data values such as yes, no. For the categories of hazards, we're able to have yes, no. data values. For the likelihoods of hazard, we're able to use data values such as possible, likely. For severity of hazard, we're able to use severe, major, and moderate. For impact, we're able to use high, very high, or low. And for the effects of the hazard, either injury, time lost, or financial loss, we're able to use simple data values such as yes, no. However, for the mitigation, which is the elimination of hazards, we're able to use simple data values such as required and not required. From after readjusting our spreadsheets on Power BI desktop, we're able to create our visuals. While creating our visuals, we were able to go to visualization boards, whereby we have different types of tools to work with. We have the stacked bar charts, we have the stacked column charts, we have cluster bar charts, we have pie charts, we have scatter charts, we have funnels, we have waterfall charts. We have so many tools on the visualization board to build our visuals. However, for the purpose of this simulation, we are just going to stick to our stacked bar charts, tables, and scattered charts. Here, we're able to highlight construction activities in this column. And then we're going to integrate our health and safety to those construction activities. Then we're able to place the construction element, health and safety element against the construction activities. For instance, we have the severity of hazard against the construction activities, likelihood of hazard against the construction activities, the impacts of the hazard against the construction activities, mitigations. We have the categories of hazards against construction activities and types of hazards against construction activities. With the help of this simulation, for every construction activities being picked, we'll be able to, the dashboard will be able to display the severity, the likelihood of the hazard, the impact of the hazard, and how to mitigate it. That is by a way to eliminate those hazards or reduce its effects. And the beauty of the use of Power BI is your dashboard could be color-coded and beautified just the way you want it. By using colors, you'll be able to differentiate the levels of severities, levels of likelihood, levels of the impact, we'll be able to measure the severity of the hazard, able to measure the likelihood of the hazard, the impact of the hazard, and even the hazard categories. For instance, if we pick any random, we've picked casting of first floor slab. We could see here that the severity of the hazard against this particular construction activities is moderate, being color-coded with green. The likelihood of the hazard is likely it would happen, being color-coded with yellow, and the impact it will have on the project is high. The mitigation will be PP is required, training or induction is required, shift pattern is required, mechanical means or alternative means of work is required. However, contract and policy change is not required. Let's pick another construction activity. Here we could see that the severity of this particular construction activity, which is farm workers' first floor slab, the severity of the hazard against this construction activity is a major one, which is color-coded in yellow. The likelihood that it will happen, it's likely it will happen. And the impact it will have on the project is very high, being collocated with red. How to mitigate it? That's eliminating the hazard or reducing its effect. PPE will be required. Training and induction before work is being commenced will be required. Shift pattern will be required. Mechanical means will be required. However, contract and policy change would not be required. Picking another construction activity, we could see. So for every construction activities, we have different display of and showing the level of the severity, the likelihood, the impact, and the mitigation. And even on the second page, we'll have the hazard categories, and we'll be able to list the types of hazards. For instance, here, we could see that for this casting of beams and columns, we have under the hazard categories, we have the safety hazards, we have the physical hazard. However, we do not have chemical hazard, workload hazard, or economics. Against this particular construction activities, we have types of hazards. We have trips, slips, and falls of persons, objects, confrontation, dogs, flammable substances. From here, we could really identify the types of hazard associated with this particular construction activities. With how they are being displayed. Therefore, in this process, integrating BIM and Power BI will help identify hazards associated with every construction activities right from the design stage of a project, and allows the project managers and even the client to be proactive in their health and safety management. With this simulation, it will hit the improvement of on-site health and safety management in the construction industry when adapted by construction personnel or professionals by identifying hazard, putting mitigation in place, that is, measures is in place to reduce accidents, incidents, near misses, and even deaths in our construction environment, hereby making our construction environment a good and safe place to work. This integration will successfully help to manage health, on-site health and safety, manage properly, and help the construction industry to grow at large. Thank you.